Hey GED math students, we have done all this work in this past week so I can get you to understand a little bit more about what we call our base 10 number system. The number system you're used to, that we're all used to, that we use commonly is a base 10 system, meaning it has 10 digits, 0 through 9. But because of that, our whole place value system that we're used to is based on powers of 10. Let me show you what I mean. Now I'm going to start with 10 to the 0 power, but I'm going to start in the middle of the page because I actually want to go up and down from here. Now, hopefully you guys know enough about exponents. You should, if you're taking your GED, that you know that anything raised to the 0th power becomes 1. Feels a little counterintuitive, but I assure you it is true. Anything to the 0 power is 1. Now, anything to the first power is itself. So if you take 10 and raise it to the first power, you'll still just have 10. But after that, it gets a little trickier. We need to do some math here. So let's see what happens if you take 10 to the second power. 10 to the second power means 10 times itself. Not 10 times 2, but 10 times itself. 10 times 10. And from that, I would, of course, get 100. So what is 10 to the third power? Well, 10 to the third power is just 10 times 10 times 10. You already told me 10 times 10 was 100. If I multiply by 10 again, I'm going to get an extra 0 on there. I'm going to get 1,000. And so that is just a 1,000 is just a 1 with 3 zeros on it. Are you seeing the pattern? Are you noticing what happens? Each time I multiply by another 10, I get another 0. So 10 to the fourth power, or 10 times 10 times 10 times 10, would end up being 10,000, or a 1 with 4 zeros after it. So then what would 10 to the fifth power be? Well, simply a 1 with 5 zeros after it. Now, if I look at these numbers, maybe that looks like a great pattern, but I want to read these numbers so you can see these are really our places in our place value system. 10 to the 0 power is 1. You know, our first place is ones. And then comes our tens place, and we got a 10 here, then hundreds, then thousands, 10,000s, 100,000s, and so on and so forth. What would the next one, 10 to the 6th power, be? It would be the millions. 10 to the 7th power would be the 10 millions, and so on and so forth. These powers of 10 exactly match up with our place values, and that is no coincidence. Now, let's look back if we were to go the opposite way. A lot of students do not understand negative exponents. They think negative exponents are going to make negative numbers, but weirdly they don't. Instead, what negative exponents do is they make fractions, pieces, and parts. We lose place value. So 1 to the 10th power is like flipping 1 on its head, making a fraction out of it, getting its reciprocal. I'd get 1/10. Or like 1 over 10 to the first power, 1/10. This is the 10ths place. Similarly, if I did 10 to the second power, that would be like 1 over 10 squared, or 10 to the second power is 100. I'd get hundredths, and so on and so forth. It'd move up like that. 10 to the negative third power would be 1 over 1,000, or thousandths. 10 to the negative fourth power would be 1 over 10,000, or the 10,000ths. And that's where I get my pieces and my parts, not negative numbers, but fractions. Okay, knowing that, I should be able to match up all these guys. Remember that the THSs are the pieces and parts of numbers. Those happen with the negatives. So I'm going to match up my positive exponents first to my whole numbers. So a 10 is just a 10 to the first power. Similarly, 10 to the second power is 10 times 10, or hundreds. That matches up with the hundreds. And 10 to the third power is a 1 with 3 zeros after it. That matches up with thousands. Okay, so from here, I see that A is 2. B is, I didn't do B yet. C was 3 I's. And E was just 1 I. Okay, cool. Now we're ready to match with our negative exponents. Remember that it's just the only difference between hundreds and hundredths is a negative sign. So we saw on the exponent. So we saw that hundreds was 10 to the second power. Therefore, hundredths has got to be 10 to the negative second power, which of course is 1 over 10 squared, or 100ths. Okay, and so let's see, B matches with 5. Okay, same thing with thousandths. Thousandths would be similar to thousands, but the exponent would be negative. So if thousands is 10 to the third power, thousandths is 10 to the negative third power. D matches with 4. And tenths, if tens is 1 to the first power, then tenths is 10 to the negative first power. I'm sorry, I screwed that up. Let me say it again. If tens is 10 to the first power, then tenths is 10 to the negative first power. Looks almost exactly the same, but the exponent is negative to make it fractional. So F matches with 6. Okay, I realize this is complex. It really is. You needed an understanding of exponents and of place value in order to understand this, but I hope you're starting to see how our number system is straight up based on powers of 10. That's what place value is, powers of 10. Awesome. If you have any questions about this or any other GED math topic, be sure to drop it in the comments, and I'll do my best to answer it.